Cool. So my name's Aidan, and yeah, as Sebastian said, I am from a different background, but I'll be looking at semantic search using Mori Taxonomy. So we'll just briefly go through the background of this. It's quite important to get a good understanding of where it's coming from. Then we'll do a quick research question, skip over the methodology a bit, and then look at the findings, which is a bit more interesting. So this is Māori knowledge. It's traditionally oral, so passed down through stories, cultural understandings, even song, and sometimes even dance. But in recent times, digitization efforts have gone underway, and now there's new issues, things like how do you store this information, how do people find it. Kaupapa Māori, which is specifically for Māori research, is where we're focusing. It's all about library records and what they have for people to find and do their learning. I guess in times past, a range of barriers were there. They were mostly physical, things like access to libraries, things like familiarity with library systems. But now that we've got digitization efforts, the barriers are more things like catalogue systems are traditionally Anglican. They might not have the kind of flexibility that you need to reference Māori knowledge. So this is not a unique problem. Actually, it's seen for most Indigenous peoples. There's research for Mexico, North America, Canada, and Australia. And overwhelmingly, the solution is empowerment of Indigenous people. So empowerment means the knowledge should be shared in a way that makes sense to the Indigenous people. It should be stored in that way, and it should be accessible how they would traditionally understand it. And that's where the Ngā Upoko Tukutuku working group comes in. They've come up with a kind of thesaurus that essentially lists a bunch of Māori metadata, which is used as topic assignments to different resources. So if we consider it, it's basically a thesaurus. So it's got preferred terms, alternative terms, and that could be something like a topic about a dog, and an alternative term is canine. A related term might be wolf, broader, mammal, narrow, golden retriever. And essentially the crux is that they have three main tenets that have been considered for every word and how it relates to other words. And so mind, which is the kind of Anglican experience, which is the universal truth, it's the understanding, the literal meaning of a term. Spirit, which is the whakapapa, it's the history of the words, where it comes from. And people, which is how the community uses the word today and how it's understood in modern context. So this data set has been made, trying to stay in the middle of all that. And if you were to consider the Anglican Western approach, that would kind of be way over here at the bottom of mind, very detached from any sort of spiritual community understandings. Cool, so methodology. We go from an ETL process, extract, transform, and load. We go from a MARC database, which is very niche. It's from library data systems, mainly used for cataloging. And it's a very well-defined, very large schema, which takes a lot of reading to even understand these little shorthand terms. Anyway, so we have a Python script that will just pull that apart, convert it to Cypher queries, and then push it all to a graph database. And what you're looking at, that is the terms there as a graph. And this is the same information represented on both sides. It's definitely a lot more human readable as a graph. Oh, and the edges are related or broader, narrow terms. So overall, the graph is not huge. We have about 7,000 terms. Most of them are undefined, which means they don't specifically appear in the the metadata set. That's not really an issue, but we'll look at it in the next slide. Library records, we only have about 1,000. We've got efforts underway to get more, but currently 1,000. And if we look at the terms, so yeah, like I said, we've got a large amount of undefined terms. What does that mean? It means we don't know the scope of the term. We don't know the definition of the term. Is it a problem? No, most of them are alternative forms of one term that already exists. So it's not a big deal. Some of them are from topic terms, from like the records that we already have. They just don't appear. And often, unfortunately, they're actually English, just because they appear in the definitions. I guess, so it's not a big deal. So the next step was to do some clustering. This assault to your eyes is all the clusters shown on one graph. Yeah, essentially the main thing to understand here is we use the hierarchical clustering. So we're just trying to get good segmentation between the terms. And then we've labeled the clusters using betweenness centrality measure. Essentially, we're just finding terms that connect other terms together within a subgroup. And we also do a little sub-step of looking for common root nodes, as in the broadest term. Unsurprisingly, top 10 make up the most of the terms. I guess it's kind of interesting because the data set has been created to catalog existing resources, so you could consider this as an overview of the resources that currently are. It's what exists. Yeah. So I have an example of just, this is using Neo4j Bloom, which is just a visual representation of the graph. It's not precisely how we did it, but this is how you could understand it. So what I'm doing here is bringing up one of the smaller communities. We'll just run the betweenness algorithm, and then you'll see one term will kind of leap most of the terms together, and that's the high level, it's jewelry. But if you go from this view into a hierarchical view, which will list the broadest term at the top to narrow, it's quite successful, and as you go in, you'll see things like greenstone pendant or different types of jewelry. Cool. Cool. So the most prolific one, largest group, is for plants. It's not super surprising because there's different types of the same plant, and where they are, they have different terms. The interesting point here is this graph is force-based in its representation. So what does that mean? Nodes that are connected are close together, and those that aren't get pushed apart. So what you see is for nature, there's like a really great little cluster that's very isolated from other nodes, very concentrated, and I don't know if you can see on this slide, but they have a lot of common ancestor nodes with lots of edges going to them. So just keep that in mind as we look to the next one. I've just taken 4 of the kind of communities that represent what the metadata is trying to succeed in, which was those 3 tenets of mind, community, and whakapapa. The interesting part here is these communities are not kind of clustered in one area. They're spread out throughout the whole graph. What does that mean? It means they have lots of connections to other nodes. So terms for things like Tikanga, which is culture, and pretty much cultural identity things, spread across the graph, which means they're connected to different understandings and different terms that might not be related traditionally in the European understanding, but for indigenous languages they are. So what's useful about that? Now that we've got this taxonomy and we've got library resources, we can start searching for things. I've just listed 3 here. Regular search, which I guess is if you were to say, I'm looking for something about feelings, then you would get all resources that have a feelings tag. Narrow search might be, I'm searching for feelings, but you'll get things about love, about sadness, and broader search would be things like emotional well-being and mental health. So as an example, I think I'm going to search for, I'm searching for ocean birds. And what you can see is there's no resources with this topic tag. But if we then went in and said, okay, we'll do some narrow searches, then perhaps we'll find something that has things about particular types of birds. And here it's hoiho, that's a little penguin. And then you've got some resources that are about that. And then just on the flip side, if you did broader search, you'd find things maybe about birds, about mammals, about the physical environment. And it's obviously going through a much broader search with a broader semantic range. Cool, and if you consider this on the flip side, if you were to have a resource already and you wanted to find similar things, okay, well now we've got some sort of semantic traversal we can do. Each resource has some tags already. We can use all those tags and we can go through the taxonomy and find any of the closest resources. We looked at 4 types. Essentially they all have 2 main approaches. One is the shortest path length to another resource, and the other one is kind of the relevant depth in taxonomy. So is it super narrow or is it very broad? And you kind of penalize if you're broad and you succeed if you're narrow. Don't know how much time, so I'll just, okay. So summary, essentially I've explained what the metadata is. We went from a MARC database to a graph database, and then we found some great insights. Pretty happy to find out that the metadata was successful in how it worked and what they were trying to achieve. Semantic search and similarity. That's great. I think the similarity measure was cool because it was a bit novel, and semantic search was successful in actually traversing through the metadata, through the taxonomy. What do we need? We need more library resources. Again, that's underway. Happy to provide them. Taxonomy, exploration, and integration of the library. How can we bring this graph into the search system? I guess that's a whole other question for people that aren't doing data science but making websites. Taxonomy, exploration. Like I said, there's a lot of undefined terms. Is that important? I guess we could look into that a bit more. And there's also terms that come from topics, so we could use that to explore what resources currently exist. Yes, we need more Māori knowledge. It's not actually that prolific. There's a very defined range. In my data set, it was a lot of children's books, which I was like, whoa, we've got so much children's books. But then it's like, on the other hand, it's like community and mental health, and it's really distinct. I won't go into more detail. I'll leave it there unless anyone's got questions. Cool beats.
Questions?
Thank you for the talk. Can you say a little bit more about how you find the communities in the graph?
Sure. Oh, dang, I didn't put it in. Essentially, I tried to automate it a bit. I used a Python script. I ran it individually to do the communities. It's hierarchical. I didn't look into separating the hierarchies and stepping through them. I guess that could be interesting to find out when it thinks we need to merge. The example would be family and Māori knowledge. Not really related, but they're grouped as one category. And I did use the betweenness centrality to find candidate nodes, essentially, and then I used those to find common ancestor nodes, and that was kind of the high level At the end, I had a group of 3 or 4, and I would manually choose the one that made the most sense. But you got candidate notes from the start.
Just a comment from my side, right? So this is part of a bigger project MBIE sponsored called Tikanga and Technology, and so the people in this project, Māori, really emphasize how useful this can be to especially children at school who are not able to search in their native language, right? So this is sort of the first step towards that they can really access library resources. The people who are working there, they're doing all of this manually at the moment, so there's no automation whatsoever in there. So this is sort of the first step towards that, and we try to build from there. Just some more background knowledge on that. Thanks, Aidan.